All right, guys. This is the lesson for March 25th, Wednesday. This is normal form of a linear equation. Okay, so on the notes, if you printed them out or if you're just looking at them here, I have some forms of lines that you're already comfortable with, right? You all know, love, and adore slope-intercept form. You know how to use point-slope form. You know about standard form and how, A has to be positive and there can be no fractions or decimals, right? You know all this stuff about these kinds of lines, and you learned vector form this year. So today you're going to learn a fifth form. It's called normal form. And I'm going to derive it for you, and then we'll add it to the chart. All right, so as far as deriving it and how this works is you can name any line if you know a line segment going from the origin to the line perpendicularly, and as long as you know the length of it. So we're going to call this line segment right here P. That's called the normal. And if I draw another little right triangle and I call this phi, right? It's a Greek letter phi. And I call this side X and this side Y, I should be able to name this ordered pair. This ordered pair, let's see, the cosine of phi is the adjacent side over the normal, right? So that means that this, if I solve this for X is equal to P cosine phi. And then if I did the sine of phi, that would be the opposite side over the normal. And if I solve this for Y, you can see that Y should be P sine phi. All right, so I've got the ordered pair of that, excuse me, that ordered pair, excuse me, just that ordered pair. I'm not sure what the heck I'm even trying to say. Okay, so next, let's figure out what the slope of the normal is, right? The slope, and again, if I use this as sort of a slope triangle, right? It's the change of Y over the change of X, right? Or if you think about this point being 0, 0, and this ordered pair being your other one, if I did Y minus Y, I get P sine phi over the change of X, which is P cosine phi, and those cancel out. Which means, right, if that's the slope of the normal and the line, we're trying to come up with the equation of this line and they're perpendicular, the slope of the line is the negative reciprocal. All right, so now if I know a point on the line and I know the slope of the line, I should be able, using point slope form, to come up with the equation of that line. So here we go. You know point slope form, it's Y minus Y is equal to M times X minus X. Let me start plugging in the things I know, right? I know ordered pairs here and I know slope here. Y minus Y is equal to M times X minus X. Okay, so now I'm going to distribute and, hold on, I'm trying to say, yeah, let me just, hold on. Yeah, no. I'm going to fraction bust, change my mind. I'm going to multiply both sides by sine of phi. And over on the side, if I fraction bust, the signs cancel out, and I'm going to distribute. Okay, now you'll notice some things have p's in them and some things don't. So I'm going to do a little bit of housekeeping. Everything that doesn't have a p in it, I'm going to put on the left. Everything that does have a p on the right. So let's see, y sine phi plus x cosine phi equals p cosine squared phi plus p sine squared phi. Y, and actually let me rearrange just a little bit. I'm going to put the x's first. X cosine phi plus y sine phi. And over here, if I factor out a p, you can see what's left inside the parentheses will be the big kahuna. So all I'll be left with is p. And if I move this to the other side, we can add this to our chart. This is normal form. Okay, so now when I turn this over, I've got some examples. Okay, so here's the normal form. In this formula, phi is in degrees instead of in, radians. Okay, so let's write the standard form. Standard form, just a reminder, that's on the back side if you need to look at it. For what the length of the normal is 3, so P is 3, and the angle, phi, is 60. Okay, so let's plug this stuff in. We have x cosine 60 plus y sine 60 minus 3 equals 0. Now you know what these are. You know the unit circle. Cosine at 60 is 1/2. Sine at 60 is rad 3 over 2. So I almost have it in standard form. All I need to do is fraction bust, because you know you can have no fractions or decimals, and the leading coefficient has to be positive. So if I multiply everything through by 2, here's my answer in standard form. X plus rad 3y minus 6 equals 0. All right, I'll have you look at this one. All right, so if you take a look, there's the second one. You can pause it, look at it, do it yourself. And let's jump down here to changing from standard to normal. All right, so you're going to divide every term by the square root of a squared plus b squared. Now notice this has a plus or minus in it. You have to choose your sign the opposite of c. So let's start with doing this. Here's c, so I'm going to be dividing by a negative. All right, I'm going to dividing by negative square root of that squared plus that squared, which is going to be what? 4 plus 20, 29. So let me divide everything by negative rad 29. Okay, now, if you think about normal form, this is the cosine of the angle, that is the sine of the angle. Okay, so if cosine of the angle is negative, and if the sine of the angle is positive, this thing has to be in quadrant 2. All right, so let me just figure out what, and again, you can use your calculator. It also says up here you can use the tangent of phi is b over a, so let's take a second and do that. Tangent of phi equals b over a. If you break out your handy dandy calculator and make sure it's in degrees, you will get 112 degrees. Okay, so here's what the formula looks like. It's x cosine, I'm sorry, it's not a formula, it's a equation. Sine 112 degrees minus 3 over rad 29 equals 0. And then I'll let you look at this one. Here's the, sorry, you can't see it there, the fourth one. All right, and again, you can do that yourself. There is a worksheet posted for this, and I will see you on Zoom.